お時間となりましたので、次のセッション、AI と量子コンピューターと
Okay, welcome. We will start the next session, Groovenauts Workshop, a new way of working that AI and quantum computing and robot enables. First, I'd like to introduce our speakers.
まずは QP 株式会社より生産本部未来技術推進担当
Mr. Takeshi Ogino, Technical Fellow with QP.
そして株式会社グルーブノーツより
And we are also joined by Mr. Eihiro Saishu, President and CEO of Groovenauts. Over to you, gentlemen.
はい、ただいまご紹介。
May I start? Yes, please go ahead.
よろしいですか。じゃあ、今日ですね、最終社長、グルーブノーツの社
So
長と
we have Mr. Saishu, CEO of Groovenauts, and us QP. I would like to lead this session focusing on quantum computing. Why does QP need quantum computing? And QP is driving AI and innovation. So to kick off this session, I'd like to start with my self-introduction. Up until 4 years and a half, I was with Hitachi. I was involved in different kinds of researches. But anyway, I used to be a designer and for the manufacturing section. Back in 1980s, I believe, our factory was #1 in Japan. This is a picture. This is where I used to work for. And in a peak period, we used to believe in the strengths of this factory. We thought that this factory is going to last forever. And 10 years later, what happened is that China, with the rise of China and South Korea, our sales started to decline. And in the end, we had to close our factory. And I had a big lesson. Well, when I was young, I think this was a good lesson for me. So any company could go under if it's complacent and fails to drive. Our competitors are not Panasonic, or not Panasonic or NEC. Real competitors were multinational companies. So talking about AI, I know that there are different kinds of applications. So when you think about an AI solution, users have worked with different kinds of AI providers, and a similar solution has been offered by many players. So let's say one company produces 10 kinds of systems, and to produce one system, 5 engineers are involved. 5 multiplied by 10, and there are 50,000 food companies in Japan, which means that 2.5 million engineers exist in Japan. According to a simple calculation, we need 2.5 million engineers, which means that a highly populated country is going to win. Then what should we do? There are a lot of food manufacturers that are looking for similar solution. So user company who needs solution could enjoy collaboration to find a solution. So come up with common solution and everyone could share that solution. If we could do that, simple calculation says that we only need 50 engineers. So that's the vision to enhance competitiveness of Japan. So QP regards AI as innovation. What we mean by that is that we listen to customers and convert their voice into value or value proposition. Each company has different value chain, including engineering chain and supply chain. And then we come up with innovation with the use of AI and gain competitiveness. So I work for production department, but we can share solution with other divisions. One for all is our vision. We started with AI ingredients inspection machine. It's not easy to inspect ingredients. So we used AI, and we have 43 AI projects today, out of which 15 systems are up and running. So one thing that I would like to introduce is Ministry of Agriculture project, AI-powered ingredients inspection system. Thanks to our strong partner, we were able to develop a strong system. We wanted to make it the best in the world and make it easy to use and understand. And we made that happen. Our system has been well received both at home and abroad, and we won different kinds of awards. So we developed our system that's easy to use AI inspection system. But instead of just using this by ourselves, we'd like to share that with ingredient suppliers or food manufacturers. We want everyone to use our product. Already we have received inquiries from more than 100 companies. So we put systems together. And then we're not trying to make money with this. So we put systems together. QP is not going to go after profit because a lot of suppliers, vendors extend support to us. So we want to make sure that they also make money. We are not going after, we are not greedy to enjoy high gross margin. So anyway, regarding AI-powered ingredients inspection machine, I think there are a lot of applications. So last year, back in, I think, November of last year, METI launched a project and looking at food players. A lot of manufacturers got together to discuss the biggest challenges. And one of the challenges is that the delis setup or delis filling work. You see a potato salad picture here. It's a lot of work. And it's difficult to hire people. 70% of them are non-Japanese. And labor cost was on the rise, and with COVID-19, people had to work in crowded space. It's a lot of there are a lot of risks, so we need to automate this. But it's not easy. Why? What are the challenges then? As you can see here, first, the cost is high. Because this is not just for us. We wanted to share this with SMEs. So the cost has to be low enough, price has to be low enough. If it's priced 10 million or 20 million, no one could use. Well, we wanted to reduce the payback back to 2 to 3 years, and it has to be feasible. Well, the filling is not easy. Given the current robots' accuracy, it's not easy. So the specification has to be modified. That's what we are trying to do. And also it has to be simple and compact so that anyone could use. With introduction robot, we have to realize the we have to optimize the total process, not the partial optimization. So we need to share the application with a system integrator and others, so the cost has to be low enough. And we need to simplify specification. And we are looking into details with our partner. And again, it has to be simple and compact. And the total optimization is what we are focusing on. This is very important. Even you introduce robot, you may not be able to standardize the process. And we would like to use quantum computing to calculate shifts and in an accurate manner to reduce waste. So that's the thinking. So our daily business for QP accounts for 16% of the total share, but our market share in Japan is only 0.5. Well, excuse me, the market share is only 0.5% in Japan. So there are about 60,000 people who are working for this sector. So we wanted to make this job easy for everyone. So we mapped factors into one. So the purpose is to reduce cost. And the second is total optimization. That's a big thing. And there are a lot of challenges to reduce cost. So we have decided to invite different manufacturers with different strengths. And again, we are aiming at total optimization. Boxes highlighted in yellow indicate our partnership with Groovenauts. Why quantum computing? Why do we need quantum computing? Let me briefly explain. I know the chart is a bit busy. So when you think about daily factory, we have different steps. This is workflow. We procure ingredients and then followed by primary and secondary processing and ship. So the yellow dotted line indicates PO. First, we get PO. Around 10 p.m. Prior day, we get PO. And then next day, by evening, we have to complete shipping. But our lead time, as you can see the Gantt chart highlighted in blue, lead time is 2 days and a half. Production lead time is 2 days and a half. So once we get PO, it's too late to start production after receiving PO. So we have to start manufacturing based on our forecast because we cannot incur stock out of stock. So which means that we have to incur some human resources or monetary losses. So this is demand focused. We have to come up with demand focused. Before production starts, we make a manufacturing plan. And then we have to also work on people's deployment. That's a lot of work. There are some works that can be done by only skilled operators. So there are a lot of constraints in terms of a skill set. We have to arrange people. There are a lot of conditions. So if we try to handle this with computer, it could take billions of years. So that's why we decided to use quantum computing, but we didn't have expertise. So Groovenauts and us decided to join hands because Groovenauts is the first company that successfully introduced a commercialized quantum computing service. So with that, I'd like to hand it over to
Thank you very much. Then let me explain the initiatives of Groovenauts. Can you put the presentation on the screen? Here at Groovenauts, as Mr. Ogino introduced, we are working on quantum computer and AI in a manner that doesn't require creation of program. What we are aiming to achieve is that now the society is experiencing decline in population, and due to COVID-19, people's way of work has changed. So we have to aim to be suitable or suited to the new world. So the people are spending less hours working compared with before. So more flexible ways of working and changes in the environment need to be addressed by companies while capturing expanding demand. When we thought about those necessities, there are various options to choose from, but we have to get to the optimum results. To do so, what do we have to do? Magellan Blocks is our product. It has 3 functions. And there are 3 factors that are going on in the society. So we are faced with uncertain future, but past data could be looked at to identify patterns in the past, and the past patterns could be utilized to predict what's going to come in the future. So that leads nicely into the use of AI. So what is the prediction of what is going to be the order for production transaction and how many incoming calls are we going to receive and how many visitors are we going to have. So idea here is to predict accurately those things. If we try to predict future accurately, what happens is once we know the end point in the future, we know that that's not going to be the end. But to realize that future, we started to realize that there are many options, or many potential approaches. So among those approaches, we have to identify the optimum one. So what I'm trying to say is that now companies are not trying to increase their headcounts, but at the same time, they have to address the changes in society and increase sales. Then what's going to happen is that at companies, the employees will be placed under a lot more burden and they are expected to work more efficiently. But now that we are in a time like this, from the viewpoint of individual employees, they opt for easy to work workplace where they can secure work-life balance that enables them to enjoy their life. Without that condition in place, they cannot work for the same firm for a long time. So there is contradiction among those different concepts. So personal happiness of employees and also the growth of the firm. And another important factor is the social aspect. The growth of company cannot happen at the sacrifice of society. So the growth of firm and the global environment have to be harmonized. Then there are several contradicting factors. So one person and one company and the society as a whole. If we try to prioritize one of them, then the other two or something might be sacrificed, and we cannot make any sacrifice, so we have to come to the right balance. Then there will be various conditions. Then what are going to be the best combination of conditions? Unless we have an answer ready, a company cannot get to the goal it aims to achieve. So we are now working on the challenge of optimization. As we do so, there are various methods or means. So the challenge of to find an answer to the challenge of optimization. The calculation performed by conventional computer faces various restrictions because of the excessive number of combination of conditions. So if we try to identify the optimum condition, then there will be a massive amount or quantity of calculations that are required, and that's going to be a time-consuming and lengthy process. So are we going to spend time and get to the optimum results, or are we going to shorten the timeline and come to a certain result? But we have to identify the optimum deployment 1 hour from now. So we cannot afford to spend a day to conduct calculation. So if we are to shorten the calculation, then we cannot look back on the past example. Then we have to do some forecasting. Then in that situation, what we came to is quantum computer. So the idea here is not to calculate. People say that quantum computer is good at computing, but actual calculation is not happening. Rather than calculating, what it uses is to adopt principles of physics and come to the result that would be calculated by the calculation formula. So physics laws come to the end result that would be calculated anyways by the computation. So that's why the speed is fast. So there are challenges. So energy formula needs to be utilized. So the optimum deployment of workers at the plant can be considered as an energy formula. So once we apply energy formula, then we can come to an answer using physics approach, but it's very difficult. So Now, in our service, Magellan Blocks, we are introducing formula so that all we can do is just to do a simple setting and derive an answer. So at the QP's plant, as we come to optimum shift, close to 200 people were deployed in an optimum manner, but the necessary calculation took only a couple of seconds because of the mechanism that I've just mentioned. So while working on these initiatives, we are working on various challenges. And as Mr. Ogino mentioned, right now, we are in collaboration with QP. So not just what we are trying to do is to resolve challenges that are faced by Japan as a firm, as a country that have grown rapidly the last decades. So we are now trying to resolve the social or national issue rather than trying to come up with a solution for an issue for one single firm. So what we are working on in our firm would play a significant role in making contributions. So this project has been launched. So that's the background against which we are working on our activities. And let me move on to the dialogue with you. But it's not just factories, I think, but within the firm, there are many areas where people have different desires, and that will involve various options, but the optimum combination of options has to be identified. But within the society or within the firm, there are many optimum answers. So when it comes to shift, then it's not just simply deploying human resources to different posts, but there are other challenges. And I'd like to mention some of those. So this time, with help from Groovenauts, we've looked into the calculation of shifts at the factory that has 200 workers with different levels of proficiency or skill sets. Workers have different strengths and weaknesses, and they come from different national backgrounds. So some people are not really compatible with each other. Then conceptually, people as properties have to be looked at. Then in an optimum manner, we have to combine them to get to the optimum output. If you try to do that, then firm consists of human resources, whatever department it is. So that viewpoint is needed in any department. It applies not just to direct work, but indirect type work. Indirect type work may be more complex. There may be envy, jealousy involved among workers, employees working in the same setting, and there are different skill sets and strengths and weaknesses. And how do we combine those different elements to get to the optimum outcome? If we could do that, then there would be so much we could do. Of course, companies could have different policies regarding optimum end result, but simply put, cost reduction could be one goal. But if we try to reduce cost as a singular goal and use quantum computer, then the company may end up having just junior employees. So what is optimum outcome, and what is your view toward optimum situation? Well, how I would define optimum situation? Well, it's a difficult question, but to get to optimum results, we need to have certain target or goal. Companies have different goals, department level goal, or factory's goal, or business unit's goal, or company's overall goal. So there are different goals at different levels. So if I take a macro view, so let's say if we take a factory as a society, then there's a region. Factories consist a bigger organization, which is a firm, and the firms come together to form a country of Japan. So there are goals at different levels. So at each level, there are optimum answers, and people as properties have to be fit into those boxes, and we have to combine them in an optimum manner to get to the optimum goal. So when I joined the society in the IT world, the goal of computerization was cost reduction. And if we do such and such things, then headcounts could be reduced by such and such extent. So that was the essence of the proposition created. But these days, our clients do not have an intention of reducing headcounts because it's difficult to hire resources. So they don't want to reduce headcounts. So what they want to do is to have as much work as possible accomplished with the human resources they already have. So at the food plant, is it becoming increasingly difficult to hire people? So that's why you have to focus on maximizing efficiency? Right. So hiring cost is pretty expensive. So that daily plant that I mentioned has high churn rate because the work is quite demanding. So some people find it not suitable for them and they decide to quit. So on a daily basis, hiring activities are being carried out, so the cost is high. So to reduce cost for hiring, what we are trying to do would be quite effective. So this time, we've touched upon quantum computer, but what's being done is that I mentioned that program is not created for the quantum computer, but in order to satisfy the QP's desire, no program was written. All we've done was to create mathematical model. So it's difficult to explain it, but when the changes are rapid and when the differentials are small, but if we write a sentence-like program, then every time something changes, the coding needs to be made, and that comes with high maintenance cost. But if we can describe the object with mathematical model, then it's very more resilient to changes.
So that's what I think a lot. But whether you can think of something abstract, I think is important. So through this project, I was very, very grateful is that within the QP, the optimization, what is optimization? The image, everybody had that. And what do you have as a target, as an aim? Unless this is very clear, you can't come up with a formula. So I think that was very, very helpful. And in terms of the quantum computerization, during that process, it's like this, or finding out, or being able to understand. Have you come to such thought? To be quite honest, quantum computing is something that we've been utilized for the first time. So a lot of people say that quantum computer, but something that is commercialized, you don't really come across. So as it is said, so come up with a different model, whether the quantum computer can resolve is a question mark. And as we conducted, as Mrs. Saisha said, it took 100 million years to do something, but you were able to resolve that in 1 second accurately. However, if I excuse, it's not that we've put in all the conditions. So when we put in various conditions, that requires a lot more bit, but there is some limitations which we need to look at. But what I do hope is that the qubit number increases, is that if under the current bit we are, even if we can't realize, I'm quite sure that in the near future things can be realized. So I've often asked, why does Groovenauts in the quantum computer, have they been successful? Many of the companies have only been doing testing. So at Keio University, there is Professor Tanaka, who is a leader in quantum computing, and I asked him what he thinks, and he said something very interesting. Groovenauts is not so particular regarding the quantum computing. If you were able to come up with a better result other than quantum computing, wouldn't you use that? I said yes. That sense. For somebody who is not computing, most people won't be able to come to that answer. I wasn't sure what that response was, whether I was being cheered, but there are a lot of good tools. And how you are able to utilize that good tools, I think Japanese people aren't good with that. Yes. I think that is, in the world, there are a lot of good research, good engineers who do such good research, but in social implementation doesn't go along. So I started research and I did design, and as I complete things, the purpose-oriented, you have to do purpose-oriented. So in my brain, everything is purpose-oriented. But during the presentation, as I mentioned, with AI and robot, and other countries were very good, and our Japanese industry fell, and in that case, Japan becomes weak. And I wanted to prevent that. The electronic industry, I wanted to avoid the default situation that occurred, I think was the fundamental aim. And through that, there are various tools. I think it was the factory of this delicatessen. So if everything is purpose-oriented, I think things start to go well. That way of thinking, I think, is common amongst what we are discussing today. For example, a lot of people say, let's make a robot, let's make things automative. Let's try so that we can have zero human people. But what you targeted for is that in principle people have to conduct, but within that there are simply works where humans do not have to conduct. And with the robot technology, that might be able to be possible. So it's not a 0-1, but you've been able to come with a nice balance. In other words, using robots and personnel. I'm not sure if robots have comfort, but a comfortable and effective way for humans and also for machine. I think that's where you're trying to look for. Yes, you're right. The final purpose is, this is the ultimate purpose, is the happiness of human. So as we robotize, the people who are working there, what happens to happiness? But what you realize once you do it is that this is very, very difficult. Plating is very, very difficult. There's a lot of things that you need to do. So at QP Group, we want to provide kindness to the people. That's our corporate mission. And we want to reduce these very complex and difficult works for the people. And of course, there are a lot of people working there. And in our factories, we are lacking people. And there are a lot of works that are required. So Saisho-san, you said that when you seek for happiness, what is it? And that's why we started this project. So by using quantum computing, what kind of personnel should deploy to each line? Our consultant showed to me this, but the capability, the balance of capability is very important. And if a robot appears there, and say if the robot has high capabilities or if the capability is not good. In other words, if there is an imbalance between human and robots, the work of the line drops, the capabilities reduce. So we have to standardize, level the capability of people and assign the capability of robot to a human, then the overall effectiveness increases, is the kind of thing that we came up with. So I thought that was interesting, or it's like this is something that we feel as we do AI. In the past, the computer function, because the function wasn't good, effectiveness or rationality was something that human had to adjust to the computer or the robot. But today, computer and robot, as their function increased, these can now adjust to people. So in today's era, the rationale or effectiveness is the robot or the computer adjust to the people. So as you said, Mr. Ogino, as a human, you are able to work in a very comfortable and enjoyable workplace. So that is the ultimate dream that we want to come. That's how I felt. So yes, as you said, the people where people don't want to do, we really have to reduce that. And people, robot, and machine, we have to coexist and come up, in order to come up with the max result, what to do. I think we go back. The optimization of the combination, I think, is the key. And through this project, as you mentioned, as terms of the food factory, not just for QP, but for the manufacturing of all of Japan, especially when areas where mechanization is difficult, and in companies unit, it may not be large companies, but food manufacturing factory, which are the fields that are supporting the Japanese lives. In order to make that more better, you want to contribute that, and we also want to support. And I think what we need to overcome, there are many, many things, but I think the biggest area where we need to overcome, what do you think is the biggest challenge that you need to overcome? The thing that we need to overcome, I think what you said early on, we have to reduce, curb the cost. So large food manufacturer, in Japan, there are 50,000 manufacturers. There are many small companies and medium-sized companies, and they're too busy doing their daily work, so they can't do investments, they can't do new work. But for these companies to have this system implemented at a low cost and can be used easily by anybody, that's what we want to seek. So what you're basically saying is that AI and phantom computing may be that we can't do such difficult things. There may be companies that say so, but as you had been mentioned, it's not that we're making a very difficult question from scratch, but with the existing, the structure is very, very simple, but it's very easy to implement. And if you're able to realize that, I think that would be wonderful. But through this project, personally, or what is a future that you want to aim for in closing? So what I want to aim for, so I switched from Hitachi to QP, but I want to seek people's happiness. This is the ultimate needs, people's happiness. When you break that down, what we need to do today to find out and to consume that, to go to your final mission and aim. Thank you very much. So QP is catch, copy, there's love. So for humans, happy future, that will be wonderful. And I hope that we can also contribute to that. Thank you very much for today. So this closes this session. A new way of working that AI, quantum computer, robot
終了いたします。
enables.
次のセッションは
Next session
15時50分から
will
となり
start
ます。
from
お
3:15.
時間まで今しばらくお待ちください。
Please wait for a few moments. Thank you very much.